Hello friends and my dear students, as we are just started the unit 4 of design of machine element, which is the 6th semester 3rd year BTECH Mechanical Engineering Rajasthan Technical University syllabus. So in this spring part or designing of the helical spring, we have studied about basics or prerequisites of helical spring. Then we have gone through the designing of helical spring under simple loading. So today we are going to cover the design against the fluctuating load or design of helical spring against the fluctuating load, which will be the last topic of this spring particular concern or spring related topic. Okay, so in many applications, force acting in the springs are not constant, which are varying in the nature. That's why in the valve spring subjected to the automotive engines is subjected to million number of stress cycle during its lifetime. Okay, on the other hand, springs in the linkage and mechanism are subjected to comparatively very less number of stress cycle. So the springs are subjected to fluctuating stresses. Okay, so this is also on the basis of design for infinite life and design for finite life, which we have gone through the part where we are studying the Gerver's line, Soderberg line. So this will be somewhat similar to that only. Okay, so let's consider that this particular spring is subjected to maximum load and minimum load, which is P max and P min. So you can calculate the mean force or mean load, as well as you can calculate the amplitude load PA with the help of these two equations by taking the average and mean. Now then the mean stress tau m is calculated with the help of mean force and multiplying with the shear stress correction factor, which is called as Ks. Okay, so with the help of that, Ks is 1 plus 0.5 times of C. What is C? C is Wahl's correction factor. You can calculate the value of C first, then Ks, then you can calculate the mean stress tau m. Okay, in this way you can calculate the value of tau m. Then you can calculate the value of tau a by multiplying it Kc, means by just multiplying your particular value whatever given over here, and this Kc is your what? Multiplying Kc and Ks, this will give you the whole value as Wahl's correction factor. So instead of just calculating Ks and Kc, you can directly calculate the value of K, which is called as Wahl's correction factor. By just applying Wahl's correction factor or multiplying Wahl's correction factor with 8 Pa into d divided by pi d cube, you can calculate the value of tau a. Okay, if you know these two values, then you can just draw this particular diagram with the help of these values. If your material is given, so for different kinds of material, you can take the values of SSE, which is strength against endurance, strength against yielding, SSY. You can calculate this for this particular kind of material, and for the oiled, hardened and tempered steel wires, you can get the value with the help of this, because SUT will be given for those particular materials, and SUT is what? This is ultimate tensile strength. Okay, in this way you can go through it, and after that you can draw the diagram as it is being drawn during your Soderberg line as well as your Goodman line, or whatever the values you have taken there whenever you are just calculating those values. Okay, or calculating those or drawing those graphs like Soderberg or designing against fluctuating curves. So if you have already drawn, or you can, to consider the effect of factor of safety, you can just construct the point D at abscissa like SS by factor of safety. This you can encounter. After that you can just calculate the slope by tau, dividing tau a by tau m, this theta, and after that you can apply the similar triangle principle in this by to calculate the remaining parameters. If you will apply the similar triangle principle in the graph, then you will get this particular equation by just applying the simple triangle application in two triangles which are XFD and AEB. Let's see that this is XEB, where it is X will be given, and AEB is what? XFD and AEB. These two triangles you have to take it as a similar triangle and then calculate this. Now let's just go through some numericals. This is the first numerical which we have seen in our previous topic of designing against simple analysis or simple loading. Let's see this first, and after that we will do the fluctuating load analysis. See, they started with the calculation of this particular wire diameter. Wire diameter is, first you have to calculate the tau, which is 0.5 times of SUT, then calculate the Wahl's correction factor, and after that with the help of this equation, tau is equals to 8 PC divided by pi d cube, you can calculate the value of d, which is wire diameter. After that you can calculate the mean coil diameter, Then you can calculate the number of active coils, delta. Delta is given, delta is deflection which will be given most of the cases. Then you can calculate the number of active coils. Then you can calculate the total number of coils, free length. On all the numerical, all the formulas are already discussed in your topic whenever we are discussing the previous session. Solid length you can calculate if you know the NT. Okay, NT means total number of coils multiplied with small diameter d or coil diameter d. Then you can calculate the axial gap. If you are knowing the axial gap, then divided by free length divided by NT minus 1, you can get the pitch value. And after that you can also specify, or just this picture is very essential. You have to draw this picture and enumerate all the values in this particular specification, so that you can get maximum mark in this particular numerical in your university exam specifically. Okay, and same calculation you can solve, same numerical for for your fluctuating stresses. Okay, you can go through that particular topic. If you have any kind of doubt for the fluctuating stresses as well, you can ask and try to solve most of the numerical given in the BB Bhandari book, or prefer your university exams papers. Okay, you can also refer that particular paper and solve those numericals. If you have any doubt, please do comment of this video so that we can get your query resolved. Thank you so much, and stay tuned with our Engineering College Banswara YouTube channel for more such updates about different branches of engineering like mechanical, electrical, civil and computer science. In the next session we will try to discuss about designing of belt, rope and pulley systems. Thank you so much, and stay tuned.